So this is the first video that I really wanted to walk you through in this unit. Again, you're doing a lot of reading yourself this unit, but I wanted to make sure that we talked about food chains, just because it's such an important part of this unit that we're going to be looking at. So here in this note, we're going to look at different ways that we could represent ecological relationships. So there's a couple of different ways that you can communicate what species feeds on what species. So we're going to look right now at food chains, food webs, food pyramids, the difference between them, and some pros and cons. So before we get into these differences, I wanted to talk about a couple terms that you're going to see that are going to come up when we talk about our different ways to represent relationships. The first term you're going to hear me talking about is this term trophic level. A trophic level is a feeding level of one or more organism in the chain or web. So a trophic level is essentially one organism that's kind of staked a claim for a certain spot on the food web or food chain or whatever we're looking at. So it's an entire feeding level, and there'll be a trophic level on top and a trophic level below. Kind of hard to understand until we look at a food chain or web. I'll make sure I point out the trophic levels then. Producers, you might have heard this term in elementary school. A producer are plants that carry out photosynthesis. So producers are always plants. Plants always carry out photosynthesis, and photosynthesis is how energy is going to enter in these food chains. Then we have our herbivores. You've probably heard of this term before too. An herbivore is any organism that consumes only plant material, so plant eaters. Carnivore is an organism that eats other species of animals. And an omnivore, that's an example of humans. Omnivores are animals that consume other species of animals and plant material. So omnivores eat both plants and animals. Decomposers have a really important role in these food chains or food webs. What a decomposer is going to do is it's going to break down any dead material and animal waste, and it's actually going to return those remaining nutrients. So as you go through the nutrient cycles in a little bit, you're going to see that a lot of the nutrients are recycled. If we didn't recycle those nutrients, we would run out of them really quickly. So decomposers are how those nutrients get back into the cycle. So those are often bacteria and fungi. Scavenger is something that feeds on the body of large dead animals. So you might have seen pictures of vultures before feeding on roadkill. Those are all examples of scavengers. And a parasite is an animal or plant that lives in or on another and from which it obtains nutrients. So parasite has kind of a negative connotation right now. We're going to be talking about parasites more when we look at different types of ecological relationships in our next block. So now let's take a look at different ways that we can represent species within an ecosystem. So let's start with probably the easiest one. This is one that you might have seen in elementary school, and this is a food chain. So an example of a food chain, and this is actually the same food chain you're going to see in your lab this week. So an example of a food chain might be grass, rabbit. This arrow indicates that the rabbit feeds on the grass. So this arrow actually indicates the transfer of energy from the grass to the rabbit. So the rabbit gets its energy from the grass. Then we have a snake is going to feed on the rabbit. And then we have a hawk is at the top of the food chain. So we would actually call this here our first trophic level. This would be our second trophic level. This would be our third trophic level. And this would be our fourth trophic level. What's really nice about food chains, it's a simple way of showing interactions and how different organisms are connected. So I can look at this and really clearly see what's going on. It also shows you that energy is continuously lost from all levels. So we'll talk about just how much energy in a second, but just know that as we go from this level to this level, there is energy lost. As we go from this level to this level, there is energy lost. So food chains are great. They're very simple. The downside for food chains is they can often oversimplify some of these relationships. So instead of using a food chain, sometimes we use a food web. So you can see I've made a slight modification to a food web here. So here we've got the grass, we've got the rabbit feeding on the grass, we've got the snake feeding on the rabbit, but we've also introduced the idea of the wolf. So the wolf is going to feed both on the rabbit, and the wolf is also going to feed on the snake. And then we've got our hawk, which is still at the top of the food chain. So the food web is actually more accurate. So what a food web is, it's a group of food chains that are actually connected together. They're highly complex, and it actually shows consumers that feed on many different species. So this wolf here is feeding on 2 different species. So it's really useful to actually connect different food chains together, and it's really useful to make predictions about if we were to remove a species from an ecosystem. So for example, if we were to remove a wolf from the ecosystem because of hunting or over exploitation, you would actually see it impact this level and this level. So it'd have a pretty large impact on the ecosystem. So they're harder to read, that's a downside, but they do tell us a bit more information. Lastly, we have our food pyramid, and in our food pyramid, it gives us just a little bit more information about the relationships. So here we actually have our relationships between the trophic levels. So again, you can see that first trophic level, second trophic level, third trophic level, fourth trophic level. But what it actually does is it provides information about the number of species that are in that trophic level. So for example, in this first trophic level here, you can see it's the base. The base is always the widest. Remember, that's because energy is lost. We're talking about that in a little bit. So since energy is lost, we need to have our base be the widest to give us enough energy to feed up the food chain. So at the base, we actually have the biggest population is going to be grass. The next largest population is going to be rabbits. The next largest population is snakes. And then our hawk is at the top. So the hawk population is actually limited by all the different trophic levels that are below it. You're going to play with that a little bit in your lab, in your food chain lab. You're going to look at this exact same food chain, and you're going to see how the different levels are impacted, and you're going to see how wide this base actually could be and how important it is to keep this base healthy. Now that we understand how to represent them, let's add a couple more names. So we're going to focus mostly on food pyramids right now, just because they're so useful, because they provide us a little bit of terms about numbers. So we're going to take a look at a food pyramid. Now at the base of every food pyramid, we haven't shown it here in our food pyramid up here. It's just kind of one of those things that's implied. At the base of every food pyramid is actually the sun. So all energy on Earth actually comes from the sun. So when you eat something, it's actually energy that indirectly came from the sun. So what's happening is producers, that's the very bottom base of that trophic level. So that first trophic level, we actually call it producers in food pyramids. Producers are able to take energy from the sun, and they're able to transfer that energy up. So you can actually see on the side here, we've got a line that says energy up. So energy is being transferred up this food pyramid. So at the very base, we have the sun, and the sun transfers energy to producers through photosynthesis. And then producers transfer energy. The next trophic level is called primary consumers. So primary consumers are the next trophic level up. You can see that this actual tier, the number of rabbits got smaller because we've lost some energy. So we lost energy at each step. So we're not able to support an equal numbers of rabbits and grass. So for example, if you've ever seen a rabbit eat, one rabbit isn't eating one blade of grass. One rabbit has to eat lots of blades of grass to stay healthy. So in order to have enough grass to support the rabbits, you're going to have more grass than there is rabbits. If there's more rabbits than there is grass, the rabbits are going to die because they're not going to have enough food to eat. After the primary consumers, we go up to the secondary consumers. The secondary consumers, again, we see an energy loss. So our snakes are going to be smaller in number than our rabbits are. And then our last step is going to be our tertiary consumers at the top here. That's the top of our food chain. That's our hawks. There is actually technically a trophic level above this. It's called quaternary consumers. So you can see that term right here. Make sure you write it down in your notes, quaternary consumers. So at this point here, you actually can see like a fifth trophic level. It's actually really rare because it's so hard to get energy to feed into those trophic levels. And here, this just addresses the energy loss at each step. So since energy is lost at each step, there is typically a 5 trophic level limit. So we can see 1, 2, 3, 4, and our 5th trophic level would be that quaternary consumer. Now that we understand a little bit about how energy is transferred, let's talk more about that energy flow through pyramids. So I want to address something that is called the first law of thermodynamics. So it sounds more complicated than it needs to be. If you choose to study physics, you're going to study these laws of thermodynamics later as well too. So what the first law of thermodynamics states is that energy cannot be created or destroyed. It just changes forms. So you can't destroy energy, but you can take it from one form and you can move it to another form. So what does this mean for food pyramids? It means that all living things have to have a source of energy, and that ultimate source of energy for most living things is the sun. So we've already talked about that. The sun is at the base of here, and the sun is going to transfer energy, can't be destroyed, transfer energy up the food chain, and it's going to travel up the food chain through the trophic levels. The second law of thermodynamics states that at every energy transfer, some of that energy is lost to heat moving to cooler objects. So we talked a little bit about this energy loss here. We didn't say what that energy was being lost to. That energy is mostly being lost to heat. So we are losing heat at each of these steps. So it's not a totally efficient transfer. What does that mean? It means that energy is lost each time an organism eats each other. Each level gains 10% of the energy from the trophic level below. That means that 90% of energy is lost. 90% of that energy is used by that organism to stay alive. So we're losing 90% of the energy. We're only gaining 10%. So again, that helps to explain why these levels are getting smaller and smaller and smaller. Each step up that you take, you're only gaining 10% of the energy that's available below. The movement of the energy through an ecosystem is summarized in a pyramid. We saw our pyramid here. Since we lose energy at each trophic level, the steps in the pyramid are getting smaller. And just a little word about that unit of energy. Energy is measured in something that we call joules or kilojoules. You might have seen these terms before. We actually talked about them in physics. So in physics, we talked about energy already, and we had that unit joules. This is the same energy we talked about in physics and electricity. So we're still looking at joules, or sometimes if the number is big enough, then we'll look at the number kilojoules. So that's how food chains, food pyramids, food webs work. Now what you're going to do this week is you're going to do a short little lab. You're going to manipulate different trophic levels of a food pyramid, and you're going to see how it affects all different things within that food pyramid. Good luck. Email me with any questions, and we'll see you in our next video.